Welcome everybody to Module 4 of the Race Crossing webinar series. I'm your host, Bridget Doran, and with me in the studio, virtually across the Tasman Sea, is Ken Beer. And Ken will be familiar to many of you. He has a long and illustrious career involving many aspects of road safety, street design, training, safe system, and in a variety of ways and formats into a variety of audiences. So we're going to ask Ken a couple of intro questions. Where do you currently work, Ken?
I work for Safe System Solutions, which is a specialist road safety consultancy I set up about 10 years ago.
10 years ago. And where did you work before that, if you're old enough to be working before that?
I certainly was old enough to be working before that. I worked at VicRoads, the Victorian Road Authority, in a variety of roles in technical design space, in a lot of setting of standards and guidelines, translation of Austroads guidance to local practices, managed road safety auditing, speed zoning, and a variety of different things, which kept me very busy, but very exciting stuff.
That is exciting, and quite a wide range of experience too. So Ken, in 3 words, I haven't told Ken I'm asking this, so it's going to put him on the spot. In 3 words, what do you think are the best attributes of our participants we've had in this Race Crossing series?
3 words, okay. Engaged, thoughtful, and present.
Yeah, they're great words. Engaged, thoughtful, and present. We will look forward to another engaging, thoughtful, and present session here today. And just the last question, what's your favourite insight from this whole series, given that there are 4 presenters and we're all quite different? What's one thing that you've learned throughout this series that you hadn't thought much about before?
Well, I think that people come at the idea of improving safety or accessibility or the like at different ways. And there's very detailed end stuff and there's very big picture strategic stuff. And the fact that I like to work in the detail of the engineering design, and I assume that all the participants also, like me, like to work in the details then. But it's been really interesting to see that we do get a spectrum of people with preferences, from that very big picture strategic stuff, which sort of have covered a fair bit of, all the way down to the details. So hopefully people are able to find these, the things that really resonate with them, but be aware of those other bits. So I suppose that's a little lead into getting people prepared to get into some detail.
Wonderful. Yeah, I think I've been the same. It's really great to see those different perspectives and to see how people take different things from the course, but we all learn from each other as well. So without further ado, take it away, Ken.
Okay, I will do that. I've got my slides up and running, and hopefully you can see that. Just confirm you can see that. Bridget, yep, good. I got the nod. Now, of course, Bridget is in the background monitoring the chat because I'll concentrate on trying to put this content into something coherent. And but please type your questions in the chat. I'm going to be asking you different questions along the way. And yeah, we'll get stuck into it, into the how, and the final module. Thank you for the introduction, Bridget. There are my contact details. That's a little QR code to my LinkedIn if you would like to connect, because the conversation certainly continues after this. We're always learning new things, finding new examples, encountering different challenges, and it's always useful to keep that conversation going. I do post a bit on online. So feel free to do that, or just shoot me an email at any point if you've got specific questions, as a couple of you have already done, which I really appreciate. So that's been good to see a few challenges people are facing or dilemmas from that design and engineering side. Right, what am I going to cover today? Well, I'm going to attempt to get through all of this. So we're going to go through ramp grades, lines, signs, drainage, lighting. We're going to go through, sight lines, which I'll spend a fair bit of time on because I think that's a really misunderstood thing in, crossings in general, but raised crossings as well. And a little bit of thinking about roundabouts, because again, that's a little bit of a newer one, generally in industry, that we now encourage the use of raised crossings around roundabouts, as you can see in that beautiful photo down from Warrnambool in Victoria, that we encourage that, and it provides wonderful facilities. A whole lot of boxes can be ticked with that sort of stuff. Anybody from the Warrnambool region, always interested in people's opinions of the roundabouts. It's a good polarizing the community one, which is always fun. Okay. I want to start by just really recapping, I suppose, design objectives. And that's come about from a lot of the stuff you've heard from Hafez, from Prue, from Bridget, and it's just sort of reinforcing some of this. But we want to locate those crossings on desire lines for pedestrians and cyclists to ensure that the facilities best serve the road users for efficient and effective crossings. Convenient and traversable by all path users. We want high alignment with safe system principles, and we want to consider this at a network level. So trying to get that consistency along a corridor and not just sort of isolated picking of crossings, which means that a journey can't really happen for some users or is a very uncomfortable journey. In terms of design principles, if we jump into that, I'm going to go through these in a fair bit of detail, but I put these days severity first. Now, that's a lot of designers and engineers don't do that, but I really almost am overcompensating for the lack of view of severity in design, operation, management of our transport network in the past. So there I've got reduce the severity of crashes by managing speeds for vehicles at the crossing and the conflict point. So then I'm thinking about the likelihood. So sight distances, signage, so we want that. 7 C's of signage, some of you know: conspicuous, clear, concise, comprehensible, credible, consistent, and compliant. Mouthful every time. Good drainage, appropriate lighting, and then managing speeds of vehicles and sometimes pedestrians and cyclists on the approach to the crossing point or the conflict, on the approach. So this is about ensuring that people have time to react and time to see things and act appropriately. So this one up here is about when the crash happens. This one is about trying to stop that crash happening. But I'll get into these in a lot more detail as we jump through it. But I just thought nice few little design principles to start. But let's get everybody involved, I think, Bridget. Now this one's going to be a thumbs up, thumbs down, or I like it, I don't like it, or good, bad, whatever you want to say. A positive or a negative. So you can see here we've got 2 lanes approaching. This is a 60 km/h speed zone, and you can see we've got the crossing there. So just type it into the chat, either like it, don't like it, or I'm seeing some emoji use. So if you find emojis that cover off your thoughts, and happy to chat to it. I do see a hand raised, so that might be a mistake hand raised, I think. You are welcome to raise your hand and then we can give you the ability to chat. But what are most people saying, Bridget?
Most people were saying don't like it, dislike, 2 lanes isn't good, could be dicey, not great visibility because of that. Just a general round of dislikes and nahs.
Okay. Well, I thought I'd start with this one, and because it's starting us in that sightline thinking, sightline mode of thinking. It's a little bit of more of a specific sightline issue that we face. It's a dynamic visual obstruction, we call it, and the idea being dynamic, moving. It's an obstruction that's moving. It's not always there, but you can see there in that little schematic that there is the possibility for a car in front to block sight lines of a pedestrian crossing. Now, this is generally why we don't put crossings with pedestrian priority on two-lane roads. And it's written into Australian standards, for those of you in Australia, that we don't do that. Now, there's a lot of looking at that because we have these roads that sit in that high movement, high place category, and they're really hard to deal with, and you're trying to put vehicles and public transport and cyclists and pedestrians through, and it's all quite chaotic. So you end up in scenarios where you are trying to cross pedestrians over multi-lanes and priority. So it can be messy, but the principle here really is that we should be thinking about these scenarios. And I don't dismiss putting a pedestrian crossing in this, even though the Australian standard says you can't, still do it. But you've got to think about the principles of why these can be an issue and how we can lessen that risk. So let's do another thumbs up, thumbs down on this one, which is also two lanes approaching a pedestrian crossing. And you can see there we've got somewhat similar setup in terms of two lanes. This one happens to be approaching a roundabout, but give us your thumbs up, thumbs down, or your like it, don't like it, or good, bad, and we'll see what people say on this one.
We've got a lot of thumbs up coming through so far, not too bad. Some people say they're not so familiar with two-lane examples. Some people from smaller, more rural communities, perhaps where urban environments are a bit more simple. Someone said it's okay.
Okay. Yeah, I mean, I think that there's some significant advantages with this one. I mean, the immediate advantage is that it is raised. Okay, so anything that happens is going to be at lower speed, more time to react, more time to evade any incident, but also if something happens, it's going to be at lower speed, more within tolerable energy levels. So that's just a big win. The second one is that separation, that sort of refuge island between the two lanes. So if I just jump forward a little bit, same site, you can see, and this is in South Melbourne, by the way. Sorry, Port Melbourne. You can see there's a truck and it's sort of approaching the crossing there, but you've got quite good sight lines if you were in this lane. If that separation wasn't there, you can see the significant sightline impediment that would cause if you're running next to that. So, back to that schematic that I put in there, we're really altering that to give that space for a vehicle to be able to see a pedestrian. Now, there are quite a few sort of scenarios where we see crashes involving pedestrians being struck on these sorts of setups, but when we add this in, that they are lessened. There's people overtaking vehicles, slowing down. There's just the ones that I presented, but this is a nice little option. And the raising of it does such significant benefit in terms of further opening up reaction time sightlines, which I'll get into a little bit more shortly. So I just wanted to start with that one to get us warmed up. But please, as I go, type your questions into the chat. Don't wait for me to pause and ask because Bridget will jump in at any point along the way and feed those to me, and I'll otherwise just give me ears back and go. I'm going to give you a few parameters that we tend to work with. Now, these are general parameters, and they're a general guide depending on where you're from. If you're in Australia, they're pretty much within a lot of our documentation. But in other jurisdictions, I want you to take the principles. And I will throughout what I present here, try to be principle based. I'll tell you the principles of what we use. I'll be a little less using specifics, but I do delve into specifics often. The speed, you want to know the speed your pedestrians or cyclists for that matter are coming into the crossing. And I'll talk about cyclists in their own as a separate sightline discussion. But generally, we talk about pedestrians about the 1.2 meters a second. Now, of course, if you are thinking about a crossing where there's something like a park with a track that leads straight in, and we have joggers, and we have potentially people walking much faster or the like, you're going to have to adjust a factor for that. The distance back we use very often is this 1.6 meters back. And I'll come to that. And then if we're thinking about an eye height for pedestrian, we tend to go with the 1.07. It's very specific. I think 1 meter would have been fine, but anyway, 1.07. But the general principle we're going for is somebody in a wheelchair or a child, and that's sort of a decent representation. So I needed to chuck those in as initial parameters. Now, common, I think, mistake that people make is to simply revert back to what the road rules say in terms of parking on the approach to a crossing. And they use this as a proxy for sightline clearance. So they don't do sightline calculations on the approach to crossings. Now, I think this is problematic in two ways, because there are scenarios where doing that is not enough. And there are also scenarios where doing this is way too much. And so the first one is bad because we don't believe people will have enough time to react, to evade, and if they, and then strike a pedestrian. The converse is bad because it may mean that we are unable to put as many pedestrian crossings, raised pedestrian crossings out there. So at a macro level, that's serious stuff. And I have seen councils who just don't budge from this and then do not put pedestrian crossings or raised pedestrian crossings in huge rafts of areas where they want them. But they're saying, well, we can't remove the parking because of, it being parking and all of the chaos that happens when you try and remove parking, which is a whole different issue, which we're not going to get into now. But, they want them there and it's the parking, and then the sight line can't be met. So they go, we can't do it. I'm like, wow, okay, we need to step this back. So New Zealand, for example, it's a 6 meter one, which is actually going to be easier for that second one. But I think there's some scenarios where I get quite concerned about only if you were to not work out sight lines and simply go 6 meter back, you could have some issues. The Australian road rules, which filters down to all the state and jurisdictional road rules, talks about 20 meters back for parking. Now, I'm just doing parking here. It's a common sightline impediment on the approach to crossings, right? But we could be thinking about anything, shrubs, trees, signal controller boxes, you name it, as a sightline impediment. So let's step that back to, well, what are we actually trying to do? Okay. So we've got a crossing. This is just a normal run-of-the-mill zebra crossing, right? Not raised, just a zebra crossing. So what we want to do is look at the stopping sight distance requirements there. So it's the same as SISD, same intersection sight distance, stopping sight distance, same formula, right? What we're saying there is that this blue car needs to be able to see that pedestrian approaching the crossing, have time to react, have time to hit the brakes, have enough skid resistance, traction there to be able to stop. So when we look at this, we're trying to keep that triangle clear of sightline impediments. Now, if we say that this is, let's go with 50 kilometers per hour, 85th percentile flow speed, for example, so you've got an idea of how fast it's going through there. You run that then through your calculations, and many of you do this absolutely run-of-the-mill. You're very happy with it, but you need to work out what is your reaction time that you're going to use. And we know that generally you can use a variety of reaction times which are based on sort of the expected environment and the road user's attention to a degree. And so you see there, like the large reaction times are very much in these high-speed rural freeways and the like, where people are somewhat tuned out. And you go down to a 1.5 second reaction time. And this is for these complex environments. There's things going on, it's urban, and that's appropriate to use in scenarios where you're going to put raised crossings. Of course, you always want to think about the base principles of this before you do it, but that's generally there. Then you think of your coefficient of deceleration and thinking about what you're comfortable with in that. And this is where I err a little bit aside on the caution, going with the 0.36 there. So thinking about 90th percentile vehicle braking in the wet. Okay. So there are a couple of parameters. You may adjust them depending, but you're plugging those in. And you do it from 1.6 meters back, as I talked about, and that's giving you then your SISD requirement there, which is that 48 meters. Okay, so that's quite, I suppose, that's quite a bit of distance that you want if they're coming in at 50 kilometers per hour. So if you raise it then, and this is the raised crossing training course, if you raise it, what do you do? Okay, now this is where industry just often goes, oh, I just use the normal zebra crossing one. I mean, what? There's nobody else telling me anything different, and I can't really. So that's then what I find is that we are way over catering for sight distance requirements on the approach to raised pedestrian crossing. And what does that mean? Well, that means trouble in us being able to get a lot of these out often. And we want to do what we can to absolutely facilitate these. So let me give you the alternate way to look at this. And I'm sure some of you have thought of this before, but I'm going to do it. Okay. We're still going to use the same formula because it's all about, you know, reaction time and being able to stop and all. So we're going to work out something there. If your ramp grade, so you've designed the grade of the ramp that people will transverse it comfortably at, say, 25 kilometers per hour. This is the other end of the sight line triangle to use. So I'm going to use the same reaction time. I'm going to use the same coefficient of friction, but I'm going to drop that approach speed. Now, if I do that, it comes out at 17 in there, so significantly less. Now, this, I really want you to know, these are the two bookends you've got because, well, I suppose actually the one back here is not a bookend. You could go much more sideline, but you don't want to be going too much less than this because you're starting to still get into these issues of not having enough time to react and brake. But this is the kind of way it plays out. If that vehicle is approaching a raised crossing, okay, they're coming in at, say, 50 kilometers an hour, we've said, they see the fact that there's a raised crossing there, and that's approach sight distance. Many of you are aware of that. You've got to be, you know, can they see something's coming up, right? And then, so they've seen it, they've reacted, and then they start to slow. And that then becomes this sort of critical point where they're going to make a call, right? So they're going to slow regardless. They're going to do that if there's pedestrian or no pedestrian. Why? It's a local area traffic management feature. It's people slow to navigate over this. It's like a speed hump, right? But there's that point where they're going to go, right, am I going to continue over at that speed, or have I seen the pedestrian here and now I'm going to slow, and have I got enough time to then stop? So I think that hopefully this diagram, and of course these notes are in the learning management system and you've got this, hopefully that helps you sort of visualize what's going on and why we don't need to provide these massive sight triangles on the approach to raised crossings. Bridget.
Ken, I'll just ask this just to check for myself. There's been a question about the grade of the hump and its relationship with speed. We're going to touch on that later on, aren't we?
We certainly are.
Yep.
I've got lots and lots of
just you
stuff
wait.
to discuss on that. It's a beauty.
Yep.
Great question. Thank you. Yeah, so that's just another, little diagram just to show we can think about this in a couple of ways. Now, that deceleration that I'm talking about, in 2.5 meters a second deceleration, that we won't get into that. Actually, I lied. We will get into that later when we're talking about cyclists and crossings for cyclist priority. So, tell me though, what is another way, and I'm going to give a prize on this one, Bridget, what's another way that we can, if we're having sight triangle issues, I've said, well, raising it's going to significantly help, but what are some other ways we could possibly lessen the sight distance requirement or make it so we're not as concerned about that? Any ideas coming into the chat?
Yeah, we've got one already: upstream traffic calming.
Okay, so it's something up here to slow vehicles on the approach. I like that. Give that a prize. I'll give another prize as well, though.
Someone said, Masada said, that opposite direction traffic. Something we could do about that.
So the opposite direction traffic. Yeah, well, you do the same sightline there. This one certainly got better sightline often, but you do have to think about, of course, both directions. I'm just for teaching purposes.
And there's been a couple of people said a similar thing, and I think Joseph John was the first to say curb out stands or curb extensions to make the pedestrians more visible, bring them out into the road space.
Prize there as well. So I love the fact that two of the things I'm going to talk about have been mentioned already. So it is a thoughtful group, as I mentioned.
Yeah, lots of ideas.
Yes. But yeah, I mean, your curb out stand helps, doesn't it? Because we're pushing that, opening up those sight lines. So that's one of the reasons we love a curb out or a curb build out if you're from New Zealand. I think that's what you'd call it, isn't it, Bridget?
Yeah, usually.
Yeah, build out. So that's going to lessen your sight triangle. Okay. There's this really interesting phenomenon, and to me, this is where your details of design interconnects with what we almost believe is important, and I think we stuffed it up. And it may be something that our design standards subconsciously, if a design standard could have a conscious, subconsciously is written around motorized vehicles. Because if you look into what sight distance requirements are there for a pedestrian crossing the road at a known crossing point that is not pedestrian priority, right? What we're thinking about is that this pedestrian can see the vehicle, can pick a gap, critical safe gap, and then can dart through that gap. And we've got the typical walk speed, as I put, the 1.6. So if you play that out, we're looking at, you go, okay, what's the crossing sight distance requirement at this refuged point? And you plug it all through, and we're saying 65 meters. So it's big, it's big. But we can use this to our advantage, right? If we take the right mentality towards, because if we, at the same scenario, were to try to work out, okay, well, what's the stopping sight? We have a raised crossing, we're in a better position, but we may not meet those sight distance requirements. So what we can do is think about this as approach sight distance. So a reminder of what approach sight distance is, and I mentioned it earlier. From the vehicle, you need to be able to see at ground level that you're going to have to do something, right? You have to, potentially give way or stop or whatever it is. Now, you do that by the vehicle, then sort of saying, what is that sight line to that facility? So they know that they're going to have to stop. You say 40 coming in, for example, you measure it along the middle of the lane, and you get it out to 34. So what I'm saying here is the difference between that 60 and that 34, right, means in some scenarios, it can be framed that we have an obligation to put pedestrian priority raised, of course, at these locations, because we cannot provide a crossing that is safe for a pedestrian if it's not priority, because they do not have time to react and to dart across through gaps, right? But we do have the ability to provide approach sight distance for the vehicle. So they will have time to slow, to react, and to slow down. They won't meet this SSD, the stopping sight distance, to see that there's a pedestrian, but we are meeting the fact that they do know that. So it's the better of the worst, if that makes sense. Now, the practice, though, is people just ignore the fact that you haven't got crossing sight distance, and sort of push that back as well. We can't do anything else. So anyway, I'll let that boil as I show you where this often plays out. Sometimes roundabouts are a good example. So you've got buildings often, and you can't quite meet that. But if you simply are going for approach sight distance, you will meet that, and that's makes life a lot easier. That's a wonderful scenario to have. Also, I mean, the reality would be that most of the time you'd put speed calming on the approach to all, and then that would slow vehicles and you get better sight lines. Okay. I will come back to slowing vehicles on the approach to crossings to open up sight lines a bit better, but I'm just going to put this one out there. Thumbs up, thumbs down. Or like it, don't like it. Ooh.
Lots of not reallys.
Not reallys. I think not reallys a good answer. I mean, I like the fact that we're trying to think about pedestrians crossing to the bus and the like, so that there is some thought of that. But the reason I put it up is, again, another dynamic visual obstruction. And I just think it's important as we design our crossings to think about not what permanent sightline impediments are there, but what what is going to be there. And I think this is a classic example. So the fact that, again, this is not raised causes me to have a lot more concern about this than if it was raised. If it was raised, I wouldn't like it, but it'd be much more acceptable. And you can imagine vehicles coming up here. There's no reason for them to really slow down. Okay, yes, there is a pedestrian crossing, and we'd love them to slow down, but we know people will go through just at usual speed. Some of them, a lot of them slow down. And then we just simply don't have that cyclism run. If we put the pedestrian crossing raised on a platform there, that forces people to get into that mindset of slowing down. And we know that then they've got the foot on the brake, they're in that mindset of slowing down and being more alert, being more aware, being engaged with their driving tasks. And Bridget had some wonderful stuff on that in her presentation. Okay.
Ken, we had a couple of comments about trees. Someone suggesting that removing trees can help with sight distance, which is obviously true, but it's not that black and white all the time, is it? Because we like trees.
Well, that's right. And I mean, that plays out in a whole lot of scenarios in road safety. And there was a time when, yes, there was a mentality in road safety that chopped the tree down because it's either going to, somebody will run off the road and hit it and be killed, or it's going to block sightlines. I mean, there's been a fundamental shift in that, where we as road safety professionals now see us as facilitators of keeping native vegetation and all of the wonderful aspects of it. And I'll give you a couple of examples there. We know that we can get safe outcomes from runoff road scenarios by continuous barrier systems, which mean we keep all the trees and we get a better safety scenario. Likewise with a crossing point. I mean, I just showed you, if the design engineer has said remove these trees in order to open up sight lines, but they're massive sight lines because the crossing isn't raised, well, you raise the crossing, you get a safer outcome, you keep all your trees. We really got win-win scenarios here when we look for them and we try hard. What about this one? I'm enjoying my thumbs up, thumbs down, like it, don't like it. Now, the lights haven't been switched on yet, so that's not in use. This was just from a pre/post opening road safety audit colleague and I were undertaking on this one. Yeah, I'm seeing thumbs coming up.
Yep, mostly thumbs up. Couple of comments about lots of poles and signs and clutter.
Oh, that's another good one. And right near the end of my presentation, I'll talk about my opinion that we are required to over-sign raised crossings, but we'll get to that. But I really like this. Now, there's some little bits and pieces, minor little tweaks to work on, but in general, I'm really liking it. It's raised. It's very clear, it's there, it's clear who's got priority. We've got open sight lines. Now there's little bits and pieces there. We've got, controller boxes and power poles and those sort of things, which we, be interested in, but generally that 1.6 back, we're really looking quite good. So that's good. And then you come back at night for your nighttime inspection, as you do, and pick it just when there was lots going on at the school and the netball courts just nearby to see what's going on. And unfortunately, we do see people parking in those areas. And again, that dynamic visual obstruction, parking and blocking that sight line. So it's an illegal park, but we really do need to think about, well, what are people actually going to do? And are there ways we could do little tweaks on our design to really reinforce that, be it that we have more physical treatments in the wedge there, which can be done and can be helpful. You just got to make sure vehicles can get in and out to their car parks, but do think about that as well. What about this one? Now, it's actually, this one's really hard for anybody to do thumbs up or thumbs down because you don't have any context to it. But so I won't get you to do the thumbs up and thumbs down on this one. I generally have thumbs up and thumbs down. Sorry, thumbs up on this one. I like it. It's a nice raised crossing. It's you know, it's got good sight lines. Yeah, this is the area I was worried a little bit about before. So yes, this truck could easily have come up here. There's parking restrictions, but it could have been a little bit done with that. But generally, really, you know, I think it's quite good. And another thing that, and the reason I actually put this one up is to think about sight lines to the pedestrian, not just in the horizontal plane, but in the vertical plane, right? And we talked about that 1.07 as the height of the eye of the pedestrian. Okay, and this one is another one across industry. There's people come at this in very different ways, but let me tell you how I think about this. So if you plant something in here that is going to grow up, I mean, what height are we accepting here? What height? Is it that 1.07 eye height for the pedestrian to be able to see? And well, that to me doesn't make sense. That's often used. That doesn't make sense because what is somebody in a wheelchair or a child going to be looking like for a driver approaching? Well, it's just going to be the top of their head if we're lucky, right? So what we need to be thinking about, and this is not documented in at least the standards and guidelines that I'm aware of, but the general rule of thumb is sort of 0.5 to 1.5 is your envelope where you really need to have that open. So people, it'll be lower than that actually. So that's probably, but that's a window that you want to be ensuring that we've got, so people, not only can the pedestrian have a look, but the driver can see smaller pedestrians approaching. Now, this little bit of real estate, oh, it's so attractive to the landscape architects. They want to get in there and, you know, do all sorts of fun things with it. And you know, I'm always encouraging of beautifying the areas and the like, but let's keep that to very low shrubbery in those areas and try to minimize minimize the height of anything in there. Little tip here, and again, I'm back in Warrnambool, lovely Warrnambool. And I think this one's really nice. I think they've done a great job of it. But the tip is to ensure that your angle parking, if you're going to use it, it's not that somebody backs onto the crossing. So if they were to utilize this spot as actual angle parking, you just have some issues often where people back onto the crossing, and you know, it's not the biggest road safety issue out there, but it causes disruption to people's ability to cross and walking around it, and there can be more minor incidents. But I think this is just a nice use of the disabled car park and the area next to it, and it's open and just works nicely. Nice little design. Okay. Right, we talked about pedestrians walking towards that crossing. And now I want to think about, okay, what about if we're providing a shared path crossing or a cycleway that has priority across a road? And this is becoming more and more popular, and that's fantastic, right? We're starting to, you know, see that in a lot of circumstances, it is right for us to prioritize these modes of transport across a road. So what speed do we talk about for a cyclist approaching? We got a 1.4 high height as the one to take there. But what speed are we talking about? Well, you can go in and have a look at, there's a good little bit of literature on this, and I've snipped one of those tables for some different uphill, flat, and the like, so you can get a bit of an indicator on that. TMR in Queensland, they talk about 15 to 25 kilometres per hour, and Victoria will talk about 20 and 30, and I'll take you through that shortly. But the principle is that, of course, a cyclist is going to be coming in faster. Thus, we're going to probably need to provide some bigger sight lines or some other features to ensure that we've got those sight triangles appropriate. So if we pop in there the 4.1 to 6.9 meters a second on the approach, and we've got that 1.4, let's start to unpack how we're going to work this out. Before I do this and start getting into some calculations, we've got a few scenarios. We've got a cyclist-only facility that crosses a road with priority for the cyclist. We've got a shared path facility, and I showed the previous one had the yellow, which is often used as a shared path, but some jurisdictions do them. And then you've got these sorts of scenarios where you have a raised pedestrian crossing, a wombat crossing, zebra crossing style thing, and a bike priority crossing as well. And in these scenarios, when you're thinking about sight distances, you take the worst. And the worst will be the faster of the two coming in, which is going to be your bike. However, you might want to adjust a little bit on, say, this scenario out here, because a bike is going to sort of have to slow to make that turn, aren't they? That's very different to a scenario where the bike facility comes straight across the crossing without that turn. But okay, here we go. I hope the video is streaming through. You're seeing riding along on the approach, you see that white car, and the white car has seen the cyclist, which is me, and had time to react and to slow down. But I, as the cyclist, have also seen that white car approaching, and I was able to check, all right, are they stopping? Yeah, and then I'm confident enough to continue on. Okay, I'll play it again. You can see it there approaching, and we've got those open sight lines. I'm sort of moving it around a little bit as we go. Okay. So in terms of this thinking about mutual sort of sighting, and I'll explain sort of the principles behind why we want mutual sighting there. I think that the best document out there, or that's done the most thinking about this to a degree, is the Victorian Design Principles for Raised Priority Crossings document released last year. There's some good thinking in this. Like any design, you need to be context sensitive, you need to think about your local circumstances and all of those sorts of things, but I think this is a good starting point. And I'm going to walk you through how to think about those sightline parameters. And then we'll have a pause for a coffee break, I think. Okay, so the way this works, and I've put that actual document in the learning management system in the resources, but I've also, you can look at the notes here. The way you do this is again, it's based off, say, intersection sight distance or stopping sight distance. But what we've got here is we think about what we call a travel time. Okay, now these travel times are scenario dependent. Okay, so what we will think about is a travel time for a high speed environment being 5 seconds. So some observation time and reaction time. All the way down to these very constrained scenarios, urban environments, low speed and the like, we're dropping our travel time as such down to 2 seconds. Now, for the real design fanatics out there, travel time is what's it called? Usually decision time in some sight distance calculation thinking workings in the background. But the point is that you're going to think about, okay, what is the scenario of this crossing generally? What's this environment? And then you're going to pick one of these that's appropriate. Okay. So what we're trying to stop here is that scenario where there was just not enough time for the vehicle to see the bike and the bike to see the vehicle. So we're going to want to have some sort of sight line opening. And I realize as I do that, a tree disappeared, which we just talked about. That's not the idea. I should put something else there that we can get rid of. But what I'm going to say is there needs to be a distance back for the cyclist, and there needs to be a distance back set for the vehicle. For our pedestrians, we were happy with the 1.6 back, but we're not okay with that for cyclists because of the pace they're moving. But what distance back do we go? So once we do have appropriate sight triangles here, we know that we're either going to have the vehicle approach, see, and stop, as you saw in the little video of myself riding one, or we're going to have the vehicle overshoot it for some reason, but the bike will have enough time to make that decision. Oh, okay, this doesn't look like they're stopping. So what we're going to do I've got 3 different scenarios, but let's take this one, which is actually quite a common one now. I really like it, where we're seeing a shared path or a bike facility, off-road bike facility, running parallel with a major road. It's usually because we've got road reserve there, and we can use that to build this facility. We separate it because that's really highly aligned with safe system principles because you're not mixing it with vehicle traffic. But you've got all these feeder roads into this more major road. So what we want to do is create this situation where a driver approaching that is going to turn can see a bike rider there, can see the conflict point, can see a bike rider approaching from the other end. At the turn point, we want the same thing to be able to happen from both directions, and of course, same for the driver coming from the other direction. So what we end up there is not a sight triangle as such, but I'll call it a sight envelope this time. And we want to be thinking about keeping all of that clear of sightline impediments. So a couple of things in these scenarios that we think about. Well, we're going to need to understand what we think what are we going to take as an appropriate speed for cyclists? And then what speed are we going to say that a vehicle will navigate this curb return at? And so generally we say 20 for the fact that they're going to have to slow down to turn. And again, for a shared user path, which is the SUP, shared user path, so bikes and pedestrians, will take 20 kilometers per hour as what we expect. If this was just a dedicated cycle facility only, we'd probably, we would take 30 kilometers per hour, which is, motoring along as a cyclist, you're really moving. We are seeing more e-bikes and more, other motorized scooters and things ticking along at some speed. So it's again, you might want to be a little bit context sensitive about this. So what you do is you've got those parameters, or it could be, again, this one where you're going to, again, take shared user path in there, and you're going to take your just usual 85th percentile speed of vehicles approaching, or if it's raised, which you hope it is, you can go back to the thinking that we had before. But sorry, same scenario. It's just sometimes we see them crossing like this. You're going to pick that travel time, and then you're going to go to this table, which talks about a distance A, which is how far back the cyclist would be. And you can see there, for a shared user path in a constrained, environment, you've got lots going on, we can talk 11 meters back is what we're thinking. If you've got a cyclist facility, it's only cyclist, and we've got high approach speeds down here. We're talking big sightlines. Now, I'd be concerned about these ones with the high approach speed of vehicles. It's always a concern, but that's the sort of way you use that table. And you can see there that you've got different speeds in there for the approach cyclist. You pick one of those. And then you get your B or C, again from another table. You've already picked what your travel time is. You're using the same one, the same scenario. And then you've got operating approach speed of the side road there, or in this one, it's the speed of the vehicle here, not the 20 km/h turn one, it's that approach speed, so time to know that they're going to have to react. So hopefully that sort of clarifies it. There's a few assumptions in there, 2.5 meters a second deceleration, flat terrain. You may adjust for those. So in these sort of scenarios, if you've got a 3 second, you're going to take a 20 km/h shared path speed of cyclists, and if you've got the blue vehicle coming in at 50, for example, you may elect to go lower because it's raised, but you can see there that you're talking about these 17 and 20. No, I was going to get everybody to answer that for me, but I think I'll just go through these myself, and then we'll stop for that break because we're about half time. Okay, so if you can't meet those things that you spit out, well, you can implement speed management for the cars, okay? And that's going to help. And we heard somebody come up with that idea, advanced speed management. Further advanced speed management is good. You can also slow the cyclist down. And there's certainly lots of examples from around the world of raised speed hump style for cyclists, but also the chicaning in. That can be also an advantage if you have a side road coming in and you've got a bike path that's running along here, and you deviate it back like that. I mean, it's quite commonly done in order to often give enough space for a vehicle to prop here so they can turn and prop and wait. But it also gives you some advantage because you've got a slight chicane there to slow the cyclist down a bit as well. You might consider dropping your travel time, which may or may not be appropriate, which is one of the parameters there. And then if you're really struggling to meet all this, you've got to start considering what is the function of that road, is that you've got the right function, and is this cyclist priority across this appropriate? But that's kind of bottom of the list. I was really pleased with my sort of many discussions and challenges with the Department of Transport on some of this, because it's a little bit conservative to a degree, but they said since its release, and they've been involved in many projects, this these guidelines, this guide note has never stopped a priority crossing for pedestrians and cyclists going in. It's simply that they've worked to do things like slowing the vehicles on the approach. This one's not raised, for example, but they had some drainage challenges and a few other things. But you can see there that they, instead of saying, well, we can't have pedestrian and cyclist priority because we can't meet these things, they said, well, no, we know the principles. We're going to slow vehicles, and we can slow vehicles on the approach. That gives them more time, gives them more warning, and we've got a facility where pedestrians and cyclists still have priority.
And there's a couple of questions here. One about if we do speed management for cyclists, which I know is not necessarily something that we've got a huge amount of evidence about effectiveness and things, but does that affect Disability Discrimination Act stuff for pedestrians, especially if it's on a shared user path?
On a shared user path, that
probably wouldn't do it, right?
Question. Yeah. Bridget, you're probably a far better place to answer that. But certainly where it is more commonplace, I shouldn't say commonplace, where it has been done has been on dedicated cycle lanes.
That's where I've seen it too, and I think it's like you've been saying the whole time. It's context specific, and so you design something that works in that context for everybody. And sometimes that means compromise, but it wouldn't usually mean legal compromise in terms of breaching an act. So you're on the side of the safest accessible way to do it.
Yeah. And of course there is scenarios where you put a stop sign up. I think this is kind of last resort where people have gone, well, we can't meet different things, so giveaway is now gone to stop. You want your road geometry and your whole scenario to be better, but it may be something to consider in last resorts. But raising that crossing just improves everything we've been talking about. All your sightline stuff and everything like that. And I'm going to talk after the break we'll talk a little bit about roundabouts briefly, and then I'm going to go into ramp grades and heights and signage and the like. So what do you reckon, Bridget? Should we have a little stretch break?
Sounds good. I just remembered I've got some chocolate coated coffee beans, which would be just the ticket right now.
Okay.
So what should we give people give people a few minutes?
Bridget with more energy. This could be very dangerous. Okay. I'm going to pause the recording.
See you soon, everyone.
Okay. How's the coffee been? Good? Okay.
Yeah, I'll pace myself one every few minutes for the next hour and we'll be home.
I see Jim's popped in a question around sort of consideration of when a raised priority crossing or raised pedestrian crossing would go in terms of the sort of thinking around warrants and those sorts of things. Now that's really thinking that's been pushed aside, and we go back to some of the stuff Prue was talking about, and Bridget, even her FAIRS, which is really talking about understanding the road environment, movement in place, and creating the crossings accordingly, and not being dictated by numbers. First of all, you often have latent demand, so there's no crossing there, so people aren't crossing there. And if you do build it, they will come and cross there. So you're missing that. Plus, it's also that transformation of the network and the network thinking about that we've moved away from that. And also the sort of ridiculousness sometimes we used to say, you need 20 pedestrians in an hour and we only saw 18. So the context again. But good question.
Yep, keep them coming in the chat, everybody, if you've got any questions or comments.
Yeah. Right, let me just talk briefly about roundabouts and positioning of raised crossings around roundabouts. I'm not going to spend long on this but there's two options. Okay, you can either position right at the hold line, as you see in option 1, or you can position set back, and you're talking sort of 5 to 8 meters. I note that I think Queensland stipulates absolute maximum of 20 back, but 5 to 8 is essentially a car length, so a car can prop out of the circulating carriageway. Now, to a degree, in these environments where they're high place value environments, and you've got people walking and cycling and stuff, I'm to a degree fine to go right up on hold line. It's often closer to pedestrian desire lines, so they can walk through and everything's quite good at it. However, I don't like the fact that when a vehicle is waiting, they will often be on the crossing, and that then just creates scenarios where pedestrians would have to walk around. We've got pedestrians with mobility devices and things that can be a bit messy. So this is why I suppose I say preferred on option 2, even though I'm still far and away okay with option 1 if that's what you can only do, as opposed to not having any pedestrian facilities around that roundabout, which really just inhibits people, just stops people walking sometimes, and makes it a really horrible scenario to be able to navigate around that area where a lot of people will have to cross.
You know what else I think, Ken, that I like about option 2, that there's kind of a political balance going on with convincing other transport professionals that raised crossings are a good idea. So sometimes in terms of picking your battles, if you put them slightly further away from the desire line and you get that through, that's way better than not having them at all.
Agree. Yeah, I think it's a great point, Bridget. Thank you. And there's an example of just that, set back enough for a vehicle to prop and wait, and out of the circulating carriageway, so you still get a bit of roundabout flow going on when somebody's waiting for a crossing point. So another pretty nice scenario there. There you can see the one which is at crossing hold line, which again I don't think operates badly, but I think I just pop it up there as an example. The other one I wanted to talk about is angle of approach. So, and this goes across the board. Anytime you're raising part of the road network, vertical deflection, a raised crossing, a speed hump, whatever it is, you want to do it perpendicular to travel path for vehicles. And that's so heavy vehicles don't destabilize. It's so motorcyclists aren't on a lean and the like, or on that bit destabilized. It's a little bit better for cyclists as well. Not as much of a major issue. But here's an interesting one: raising a signalized crossing, which I think is an awesome thing to do as well. I do like raised signalized crossings as well as raised signalized intersections. And but this one has some problems being on the curb, and you're going to have vehicles. So what I'll give a prize out again, Bridget. Hopefully you're taking note of a few prize winners. Good. What do you think we could do? Do we have to abandon the idea of raised signalized crossing at this location because we can't get it perpendicular? Anybody got any ideas?
So we've had a suggestion: raise the whole intersection, extend
Yes.
it out of the bend.
Aha. Well, let's give the extended out of the bend a prize. It's not actually an intersection, this one. I probably didn't clarify that well enough. It's a mid-block pedestrian. Pedestrian.
Prize for Paddy.
Prize for Paddy. So yeah, I mean, you could splay it out, or you could do different extensions to points where vehicles are hitting it at more perpendicular. which is another little mock-up that I just was sort of saying you could extend these. Now, I've collected together some guidance around pedestrians and cyclists at roundabouts. TMR Queensland has done a lot in this space. Victoria's done some stuff, and Austroads continues to work on it. They're a little bit slower in getting their stuff and moving along. But I've put those into the learning management system. I'll show you at the end where all of this is, so you can get into it to your heart's content.
Ken, there's just one specific question here about best practice on bus routes with offset from the give way line to the raised crossing. Does it make any difference if it's on a bus route?
Yeah, I'll talk about buses shortly, and I think to a degree we'll cover that. But let's talk a little about where we get to thinking about buses, because they're an important road user. I'm just popping this one up. I think it's nice. Again, you can see that chicane slowing cyclists a bit, but also giving that area for vehicles to prop out of the through lane. So the vehicle that can prop, let the cyclists go there. It's a nice example. Okay, so somebody wanted to talk about ramp grades, and I'm going to talk about so lengths of platforms, ramp grades, and the like. The general principle. Okay, let's start real basic. Okay, the sharper it is, the lower the speed vehicles will go over. Now, why are they going to go over it at lower speeds? Well, they see it and it's more, it's sharper, they will slow down. But also, people get to know how bad a speed hump is, or a raised platform is, or a raised anything, and they're common users of it, and they act accordingly. If we sign it 20, but design it 50, people work that out and they start to drift down to that. And it's so I'm going to show you a few things here. I'm going to use a fairly run-of-the-mill common raised crossing, Wombat crossing scenario here with a 3.6 metre platform length, 1.2 meters long, and 100 mil high. Quick prize, somebody tell me what the ramp grade is on that. Anybody?
1 in 12.
1 in 12.
Yes, Jim Hondrakis. This is great. We've got lots of different prize winners.
Yeah, Jim's had a win. Yeah, it's 1 in 12. So you're basically saying you've got 1,200 and you've got 1. So you got the 100 high and 1,200 long. So we talk about ramp grades in 1 in 12s and like. I see somebody put in a degrees, which we don't. Yeah, funnily enough, we don't use degrees on that. We use 1 in whatever. So it's 1 in 12. A flag now, and I'll come back to this, but you've got to think about the slope of the road that is approaching it. So, if it's like this, you're going to have to think about that and factor that in to that difference. This diagram is extremely helpful in us understanding what we're trying to achieve and what we will achieve. And what it does here is shows us for a 1 in 12 there, and you can see blue's 1 in 12, and you've got your other colors over here. And what it shows is the peak vertical acceleration that a vehicle will get at speeds traversing this platform grade. Now, what happens is that people will roll themselves into that green naturally. Okay, so that's how you start to understand the vehicle speeds that they will go to. So you can see there, that's the 1 in 12. They're going to be around the 20, 25-ish. We go up there to a 1 in 16, so it's flatter, right? We see that that's going up now around the 30. So it's really helpful to you. I've also put some ones for higher speed. These are usually intersections when you're raising intersections in higher speed environments and you want higher vehicle speed through. Is there a link to the CDM research? Great question. I don't think I put that into the resources, but
yeah, I've got a note. I've got a note for us to make sure it's a link in there.
Yeah, I will pop that in because it's good. It's very good stuff. And I've also done a little bit of help for you in collecting together the different guidance around this, so you don't have to go looking through all sorts of things. So we've got the Austrode stuff in there. We've got the Australian standards, which does talk about this pretty generic setup. We've got some TMR stuff. This blows my mind. 150 mil high. I'll show you why later. I'm just wondering which scenarios that would be, but anyway, it's just very high in my opinion. And some Waka Kotahi stuff as well. So I won't go through all of that in detail because I'm giving you the general principles again, and you can delve into those for your specific jurisdictional guidance. But if we think about the heights and of this and the lengths that you might make them, I mean, you can conjure up any scenario you want. You can sort of extend the length of the ramp, which is going to change the grade of the ramp, and thus people will be able to go faster over that with less disturbance to them as a driver. You can go higher up to that 150, and if you did that at a 1.2, you're in a really quite a very sharp and very low speed. You could extend that out. You could have low, very low at a 50, which is in some of the guidance, and you could put that. So you can see you can alter these and change these as you like, and referring back to what the ramp grade you're producing is. But when are you going to use these different scenarios becomes the question. Well, what we're trying to ensure is that vehicles slow down, right? However, we've got to think about ensuring that vehicles can navigate over these without scraping here or without getting caught under there, without backing, dropping their end on it. Now, this one doesn't have a long tail, but you do have some vehicles with a longer tail, and then not scraping and getting caught on the way out. So there's a few sort of scenarios to check through. And it potentially nose out as well under some different scenarios. So there are minimum vehicle regulations, right? So a vehicle cannot be lowered to such a point that we can't really be designing crossings that will do any speed reduction, because we've got to take this super low vehicle into account. So there's just minimum vehicle regulations in place, and therefore it's also got truck regulations as well. But buses become a really problematic or challenging one for us, but it absolutely, if you've got a bus route, does not mean you can't have raised crossings or features to slow vehicles on the approach to a crossing. It just means, again, we need to think about our designs very carefully. We may not be able to take the stock standard design off the shelf on a bus route. Okay, so we're going to get into a little bit of thinking about it. And lots of different buses, but let's talk about what the general minimum bus would be. So this will be your kind of lowest bus in most jurisdictions, loaded up and it's going to come down to, it'll be higher than 100 mil. It'll be 6 degree off the axles there, 106 degrees off Y there, and the same out the back. Okay, so that'll be your absolute minimum. You're not going to get buses lower than this. Okay, which means we know our absolute worst case parameters. But if we, and here's some more, I suppose, standard buses. And you can see there's a higher clearance usually on a 12.5 meter, and some even higher ones, and we articulated ones as well. But I'll pop them in for your reference, because remember, I'm just talking principles here, and you got to work this out a little bit yourself. Okay. Loaded up, low bus, and not even going to make it over the 150 high. So yes, you might have a lot of scenarios where you have a higher bus, but then we'll get up onto that, and then we don't want it to be stuck on top of it like that, as you could imagine. And we don't want the back of it to be stuck as well. National Heavy Vehicle Regulator and jurisdictions have some pretty good information about the specifics of different buses if you're trying to be specific about what bus you're catering for. But you'll see here, back to our Yarra Boulevard example, I mean, this is an area that's going to get the coaches, the school bus, they're taking kids wherever and the like, and this is your 100 mil high, this is your very run-of-the-mill 1 in 15 ramp grade, and this bus adequately goes over, slows down but goes over, and that's a good example that you know, these are not end of the world stuff. But if you do have an area that is getting, you know, is a commuter bus route, it's going to have those buses quite frequently. This is where some adjustments are often made. Now, this is at a 75 high and a 1 in 20 ramp grade, so it's flattened it out a bit. So a result of that, it's a smoother, easier run for the bus. But where you're starting to balance things off is now that the vehicles themselves are going to start to go through their cost. So, I mean, I think this is good. This is in sunshine. I mean, this is in buses quite frequently. And so there's that little bit of adjustment. There's a possibility to have longer ramps to get both bus wheels on, which can help you a little bit in ramp grades, but I won't go into that in detail to keep us a bit of time. Now, this is an interesting one. Again, I've got a lot of warnable examples here, but this one is 75 high, but is a 1 in 27. So that is a rise over 2 meters. And what this results in is just a very flat ramp grade, and vehicles comfortably going over it at 55, according to the CDM research stuff and the things, and absolutely, like I think even higher. Certainly, you don't notice. So this is where we've sort of tried to cater for buses and gone too far, where we've lost the effect of the raised crossing. The colour of that was probably doing a little bit more than even the raising at this point. So if you really can't make that all work, or the bus people are just so determined that this is not going to happen, I mean, this is where I think we need to be a little bit creative and go back to what is the principle we're trying to achieve. Our main objective, well, our number one objective, is to slow vehicles on the approach to the conflict point, or at the conflict point, but then also on the approach. So we can slow vehicles in other ways, and okay, this to me is a pretty good scenario in the circumstances where, now I would like to see it raised, the crossing, because that has other advantages in the sense of aids mobility for many more people. They don't have to go down and the like. It also means you only have to raise 1 point rather than multiple points. But speed cushions can be really effective. The bus people can't argue anymore because they can straddle this. You can alleviate some drainage issues if you're really stuck on drainage. So there's options here, and that's used in a variety of scenarios. Sometimes we see it with the spike down rubberized ones, which some people like, some people, sometimes maintenance people, do not like. I do recommend, as you see here, either having the 2 on both sides, even though you're only stopping, slowing the vehicle on that approach. You can see on this one that they've sort of put a little separator there. You do have the danger of vehicles navigating around it like that and just, at different hours. But extend that a bit if you're going to just do one. You can also do asphalt ones of these for more permanent treatment, and yeah, they essentially doing the same job, not quite as good, as I say, not elevating sight of pedestrian, not providing that consistent path. But if the option is nothing or this, go this. And there's some specs on cushions and how you can design them. And also when we're thinking about ramp grades and the like, there's not a requirement to have the same ramp grade in as out. The scenario where you would want to try to make sure that's the case is if you had an undivided road. Like, so you've got a divider here on this one. That's kind of important where you've got 2 completely different ramp grades, one on entry and exit, because if you didn't have the separation, then you'd have this weird scenario where it would be possibly destabilizing. But this could be pretty helpful when you in some scenarios, and I'll show you one shortly. In fact, I'll show you one now, which is a scenario having a look at. Actually, one of the past participants put in as a question during the course, and how would you rethink this? And we have to abandon the raised crossing because we're on quite a slope here coming down the hill, quite a slope, and that's going to present quite a few challenges for the ability to clear buses over this. And it is a bit of a bus route. So how do you think about this and design it in order to be able to cater for that? Or is it just you have to abandon the raised crossing? Well, this is, I suppose, the scenario. Of course, I've exaggerated everything here to make it, very vivid so we can all see it. We've got the bus coming down the hill, and we've got this, because we're trying to make the path flat. So the bus will get stuck. So you can alter your angle. Now you can't go too far with this, but you're certainly able to alter the angle there. And there's a discrepancy between Austroads and Australian standards on this. Austroads is far more, well, it's not a discrepancy, it's a clarification that if you're using asphalt, you can go a more severe angle on this. But you can extend the out ramp as well, because remember, we're just trying to slow vehicles on the approach. Like once they've slowed, they don't care. You could flatten this out to eternity if you wanted. So you can really sort of start to play with that exit. And you can create scenarios where the buses can go both ways, but it's a slightly altered ramp. Now, there's a little bit more cost to it, but you get some pretty big advantages. So, something more like that in these scenarios can be really useful and successful, and you're still getting what you're trying to achieve out of this. And it's very different, entry and exit grades there. And again, of course, if you go into the details of that, you just work out, well, we can't do that. That's where something like a speed cushion on that approach would be the one, because that's the one you're really going to be dominantly worried about. Yeah, this one's going to be slower because they're coming in. You wouldn't really want to put a cushion there just for the fact that a vehicle is sort of turning in there and they're going to get some weird angles on that. Anyway, I better keep ticking along because I do need a couple of minutes to show you through the learning management system at the end. But jump in, Bridget, anytime if there's any questions that I need to deal with.
So far, so good. Let's kick on.
Okay. So lighting. Lighting is often a huge cost impediment to getting in raised crossings. And the levels of lighting required in different jurisdictions vary. And the principles, though, are that the higher speed vehicles are approaching, the more light you want. So it's more obvious. So in lower speed environments, your lux levels can in theory, come down. A document that many of you will be familiar with, 1158, is the lighting of pedestrian crossings. Again, predominantly thought about for not raised crossings, so we're thinking about some challenges there. But the theory is that you want to be lighting from both sides, ideally, and if you do a very base level first principles lighting assessment, each of these points, so you've got a vertical plane and a horizontal plane of light that you're trying to deal with. So you're looking at light lux levels at these different points, okay? And one at the middle of the crossing, and one at each side of the crossing. So that is the way you'd do it. The lighting then of these different shared path crossings or cycleway crossings goes back to what we're thinking about in those distances A and C or B on those different scenarios, and ensuring that we've got it lit at that point, but also through that point in order to do that. Do we need a light back here? Well, not so much, because the headlights here will be enough of an indicator for the cyclist to see that the vehicles are coming there. Now, TMR has a sort of 10-meter setback. In general, I prefer to work it out myself, but that's up to individuals. So lighting, so before I finish on lighting, the first thing I'd say is that there is a lot more solar lighting available that is meeting the needs for pedestrian crossings, raised pedestrian crossings. A few of us are doing some work to try to push along industry to be more considerate of, I say industry, I mean Australian standards and Australis, to be more considerate of approach speed and risk profile and the lighting levels. We don't need to, in low speed environments, low approach speed, light these things up like the MCG. We can accept that the risks are lower, and that some lower lighting levels are appropriate. But I really do encourage you to have a look at some of the solar lighting options, which will save you an absolute heap, plus are better environmentally friendly. Drainage, another challenge that often comes up for our raised crossings. I'll go to our diagram here of ways to deal with the deluge when you're thinking about raised crossings. So I popped the first one in just as a, well, I popped it in as a joke, but it's maybe not a joke. Again, it was a road safety audit I was doing with a colleague, and sort of scratched our head about it, but it's really not, serving a purpose in terms of people being able to navigate this, except for the very able. So let's talk about, so low ramp height is an option, and we just talked through ramp heights, but you can get your flow over that. In an ideal world, you position your raised crossings at high points, so the water will go either way. However, you don't want to be just positioning it there because it's easy for drainage if it's not on a pedestrian design line and it's not going to be used or the like. So the option to ramp down, ramp up should not be forgotten. And this is often a very interesting one, and people sometimes get quite passionate about not liking it or liking it. And again, I say this depends on the context you've got. I'll show you some examples, but if you've got the ability that it's, whoa, what did I do there? Sorry. If you've got the ability that you can have a fairly flat approach and ramp up over a period, it is accessible. It can provide that facility. If you're coming in steeply and then going up, of course it's not going to work for people on mobility devices and the like. Then there's the box drain option, and then pit and pipe and get it water under, and probably have to increase your pipe size and things like that. So let's just look at these in a little more detail. So that's the one, where we go under ground subsurface drainage. This is got cost, and this often is where people get to and they go, well, we can't deal with the water, so we can't do the raised crossing, we can't do the raised facility. Again, I say, if you can do this and it fits in, it's great. Let's do it. But don't let the fact that maybe you can't do this stop you from having features to slow vehicles. The next one was that box drain, where we're laying a plate over the existing drainage channel and connecting it up. So we get that nice flat run through for pedestrians and the like. So this is pretty good, except for it does potentially clog up and you need to maintain it. So there's an example. Again, it's a nice one, isn't it? It flows through nicely, keep your bluestones, and everybody's happy. Again, I'm just happen to have these photos handy of this one where it's got leaf litter, it's clogged up. So you need to factor this in, and it does need regular attention, which is annoying. But again, the facilities can be provided. We just might need to do a little bit of work on it. Providing wider ones could be better. They still can clog up. Of course, other drainage facilities can clog up as well. So these sort of features where you can cut out your curb there and flow water in, I think are quite elegant, and you can provide really nice features with that. You can often use these areas as sort of mini swale areas or retarding basin sort of areas where the water can flow. You could have rainwater gardens and nice beautification. I'm not quite a water sensitive design expert, but I'm sure you've got people available you could talk to about how you could utilize these big areas in a nice way. So there's another possible win. So I talked, I think, about this enough that I say that, this one I actually think is okay, and watched people in mobility scooters navigate this, and they were fine and able to do it. The distance there is important, that ramping up and the flattish entry is the really important part of it. And you can see this sort of stuff can work quite well in different scenarios, but you need that ability to ramp up over a distance. This one, though, I don't think is going to cut it, and didn't, this is where we're seeing quite a drop down and then that raise up, which is going to be very problematic for users of different devices. And this one, is one where I watched this lady sort of slowly navigating up this. I thought, would have been nice to be able to not have to have her slowly do that. Then I thought to myself, well, pretty happy it's a raised crossing, so vehicles are going to be going slow anyway. And I wonder what the challenges were associated with drainage on this one. I wasn't involved in this one, but yeah, I think if you can push for that consistent grade, it's better, but don't dismiss the raised crossing. So the other thing around that is the one that I probably didn't put in there is to go to speed cushions. You absolutely can't deal with your drainage challenges, or there's the road is some critically important floodway or something like that. The last few minutes, and I'm going to point you at lots of documents anyway, so you'll be able to follow them up. But of course, looking forward to your emails and phone calls about your specific issues, because I may not have given you enough on specific ones. But the Australian standard, for those in Australia, does lay it out very easily to understand. Well, I find it easy to understand, hopefully. But it's all done in this one diagram of how to sign a raised crossing, and you can see there some sort of advanced warning of the crossing, the regulatory crossing signs, which usually are put, on that approach, but the other one on the back of it, and then over there, your areas where you don't need vehicles, so your signage associated with that, and something to warn of the raised area. Now, that's a lot of signs. And it ends up, you're finding lots of signs on a particular post. Reminder there, 2 metre on that, just so people aren't hitting their heads on it, and it's not also blocking sight lines. But you do get these sort of many signs on a post, or many posts. This one, interesting one, people going nuts about, you can't put 2 regulatory signs on the one post. I don't really care at this location. That's just my opinion. If you don't want to, it's just it's a low speed environment. Sorry. This is a concept we're coming up with as different Australian standards are looking at it, because instead of having to do all of that, the legs, the raised thing, we at least start combining a few. I think that would be helpful. Going to key marking in Australia, and of course in 1742, you can find all the details about that. The little triangles in New Zealand, which are a nice little feature. UK similarity there, and the diamond on the approach as an option. And there you can see one from New Zealand as well, and the different is the legs. They use this little doohickey. I can't remember what it's called though.
Alicia?
Yes, Alicia, thank you. Prize for you, Bridget. Yeah. And then there's some different, so you saw there in quite a few of my photos that when you have a shared path or a cycleway that crosses a road, what you essentially mark it as an intersection. Okay, you are creating an intersection where you would use a giveaway and a giveaway so that that is a road which has priority, the same way we would if it was an actual road that went through there. See that there? This is like saying that there's a road. So that's how you sort of think about the signage of those. And you'll see there that we're using, every jurisdiction at the moment seems to be using Queensland's signs for this, although I understand Victoria is coming out with a standard signage, but you use your giveaway and then your 2 pedestrian and cyclists underneath. Some stuff in there pointing you at some different references associated with when you would use flashing lights or not, tactile ground surface indicators, raised reflective pavement markers, all in there coming out of the different Australian standards or supplements, which I think are good. And you come up with very, interesting signage scenarios, slip lanes, shared paths to slip lanes, and yes, and then the combination paths and the like, where this is sort of this whole crazy signage stuff that we've got to do, but you're giving the regulatory setup for the pedestrians to cross, you're giving the giveaway to cyclists for the cyclist facility to cross there, and that's the way that ends up meeting your requirements. See this one, there's a lot of signs on there trying to tick off all those boxes. Always keen for innovation in this space, so if you've got good ways to do this, as we were trying to consolidate signage, as you saw in those mock-ups, I think we need to do a little bit of work on it. It's just too much sign. My last one, which I'm not going to talk in detail on, is just your pavement and your pavement setup, and then we could do a whole course on this, couldn't we? I'm not a pavement expert, but the one sort of important thing I think to remember is that boxing out of your pavement in order to ensure that you get a defined lip and this doesn't sort of chip away. The concrete is much easier to get defined changes rather than the asphalt, because the roller will sort of flatten things out in its own right. So yeah, concrete can be really beneficial. You can see it here, really nice concrete, a bit more expensive and a bit harder to construct as well, but you get some really wonderful results if you're able to go with that. You can also colour it a bit, make it a different, so your white stands out a bit. Okay, any questions come in there, Bridget? I did race a little bit to just tick off some of those things there at the end.
Yeah, no, an interesting question around raised pavement markers, RRPMs. The questions says for road humps, but kind of just as a speed management thing. Perhaps I've seen some of them on shared user paths, which I think are a good idea. What are your thoughts on those?
Yeah, so I think I pointed at a part of the Australian standards that talks about them. Again, it's about the scenario you're in, because you would lay them across the front of the pedestrian crossing to highlight that it's there, and that's important if there is a bit of a higher speed vehicle approach or the like, but in the lower speed environments, it's not seen as important. Okay, so let's just quickly show people how to finish off this course, because I'm going to actually make you do a little test. Are you seeing the learning management
Dashboard.
system?
Mhm.
Good. Okay, so you're in Rays Crossing December, and you've got all of the presenters there. There's a tick next to Hafez's because there was a little assignment task with that. There was no assignment task with these two. There is going to be an assignment task with mine. So click on me, go to the how. You've got my notes. You've got a little sheet about some of the signage stuff, a little article for your interest. But you've got a little quiz to do here. So you click on the quiz and you've got 3 attempts at it. We need you to get 80% to pass. I don't think you'll find it too hard if you've been listening, but it's simply multiple choice or, drop down answers, true and false, and the like, all from what we have been talking about. So you're going to get in and you're going to do that, and it's going to take you a couple of minutes. It's only going to take you a couple of minutes to do that. And then the last thing you're going to have to do before your certificate is released is to provide a little bit of feedback on the course. It's very short again, it'll only take you a minute, but just tell us what you liked and how we can improve it, or any other thoughts you had about the course. And then your certificate will release and you're able to download it. You'll also get something in the mail, as I hope you already did. But up here, I want, oh, sorry, isn't it? Yeah, no, it is up here. Course, no, resources. Here it is, resources. This is an important one because I talked about a lot of guidelines and standards and the like. Road design and engineering resources. And there we go. Those ones that I've been talking to, all in there, all for you to have a look at, and that will keep you with lots of reading material for the festive season break.
Keep everyone engaged, thoughtful, and present.
That's right.
For the rest of their careers, or until their next webinar series.
That's it. So I do remind you to do that quiz, fill in the feedback, then your certificate will release. You'll get a email reminder if you haven't done that. But thank you, Bridget.
Thanks, Ken, and thanks everybody. And do feel free to contact any of the presenters if you have comments or questions, because we're obviously all very keen and on the content, on the topic, and on hearing from you about how you're getting on using the material, and what challenges and victories you encounter as you do so. So thanks everybody so much for your engagement, being an excellent group. And yeah, have a great Christmas, everyone.
Thanks, everybody. Bye. Keep in contact.